Hi guys, my name is Reddy Naidu, registration number 18BEC0199. My DA to test design and implementation of floating and divide fused architecture. The explanation. The floating point unit mentioned in our syllabus is a base model and I have chosen a journal that consists of modification to traditional systems to enhance performance. The journal I have chosen is related to syllabus is to architecture changes. There are 7 modules. Introduction to computing systems, processing unit data, processing unit control path, memory subsystems, I/O subsystems, introduction level parallelism, microprocessor. These topics relate to value and operations and relate to value discuss different algorithms regarding division and multiplication, etc. And innovations are done. Existing exponent processing, BIT interval, allowance shifter, LPO, carry, propagate adder, completer, normalization shifter, rounding, sticky, remaining adder. Tabulated results and graphics using Microsoft Office. Example of floating point DF unit, floating point adder, obtained output after 7 cycles. Floating point subtractor after 4 cycles. Floating point multiplier, obtained output after 5 cycles. Floating point divider, obtained output after 50 cycles. In this table is shown, the table shows the example of floating point division followed by addition, where F1 and F2, F3 are the 3 floating point numbers inputs and Z is the output, which is represented in 32-bit IEEE format, where S is sign bit, E stands for exponent, and M is Manticia. Simulation result and calculated difference. Proposed architecture different paper using Microsoft VASO software. OP code ALU data output clock this adders multisim or CAD tools in RIG systematic or proposed action floating integer point multiplier. Section of result proposed FP integer multiplier checker. Internal structure of individual 12 multiple module. The comparison of architecture with existing architecture. System design. The system architecture design, sometimes simply known as the system design, is a conceptual representation of the components and subcomponents that of system. System are a solution architect are the people who know that the component to choose the specific use, make the right trade-off with awareness and bottlenecks in overall systems. The basic components. System design involves assembles the right components to solve the problem at hand. There are thousands of components or stacks available from different cloud providers. See, virtual machine, load balancer, database, cache. Proposed architecture. In order to circumvent the opposite problems, the paper proposed a novel combined integer and floating point multiplier architecture, CIFM. The CIFM can perform both integer as well as single precision floating point multiplication with a single dedicated 24 into 24 bit multiplier block design with small 4 into 4 bit multipliers. This is the driving force that leads to proposal of CIFM architecture suitable both for integer as well as floating point multiplication operations. The reverse CIFM design as proposed here will form the basics of the completely reusable FPGAs. CIFM architecture: controlled shift round MUX multiplier. The advantage of proposed design over existing design. For addition and subtraction, to ensure both operands have the same exponent value. This may require shifting the radix point is one of the operands achieve element multiplication and divisions of a floating point operation may produce of these conditions. Exponent overflow under overflow. Exponent overflow. A positive exponent exceeds the maximum possible exponent values in some systems. This may be designed as our exponent underflow. A negative exponent is less than the minimum possible exponent value. This means the number is too small to be represented and it may report as 0. List the merits and merits. The overflow expectation occurs when the result is an exponent of 0 or is if the operator is empty. The underflow expectation occurs if the implicit bit of result is 0, if the exponent is -120 or this is too small represent fully single precision forms. The main objective of this series was to develop the resource for designers to implement floating point adder on FPGA. This kind of work has been done before as we believe it. It a great help to in custom implementation design floating point adder on FPGAs. Applications of proposed design. The closeness pointing representation to actual values accuracy. All these special numbers as well as other special numbers are subnormal numbers represented through the use of special bit pattern is in the exponent field. On unified structure to solve the multiple floating point matrix operations in unified hardware structure. Matrix addition and matrix subtraction. The flow chart. Start. First I is equal to 0, first I is equal to 0, F is equal to 0, F1 is equal to 0. The just sheet of designed and implementation of floating point where abused architecture.